Another milestone in our pocket. We finished the transport layer and are moving on to the application layer. In this video, I will provide an overview of the application layer. The application layer protocols we will see in other videos. A quick recap first. We now have the networking infrastructure in place to enable a variety of applications. We can successfully transfer packets from a given application process on a given host to another application process on another host. Now that the process-to-process transfer mechanism is in place, when the application developers develop these applications, it is very important that they understand the building blocks, that is the physical layer, the link layer, the network layer, and the transport layer that enable this particular service, and also understand the interaction between them. At the very minimum, you need to understand what UDP entails, what TCP entails, and make the right choice and implement the required functionality to enable the application service. A bit of a history first. Notice that I'm using the word internet services here. Not all internet services translate into application layer protocols. Some services are put together by what application protocols already exist. The foundation to the internet was laid sometime late 1960s and early 1970s. Email was one of the first killer apps. In fact, it came into being sometime 1971 itself. At the time, in the 1970s and 1980s, a lot of the applications were text-based. So we had telnet, file transfer, news groups, text-based chat, so on and so forth. The 1990s saw another disruptive application in the form of World Wide Web. Later, we saw the Google search, lot of e-commerce services provided by Amazon, eBay, PayPal, Craigslist, so on. The late 1990s and early 2000s saw another killer app, which was the point-to-point file transfer. At that time, this service accounted for nearly 75% of the internet traffic. Then slowly these social networking services started in the form of Facebook, Twitter, a lot of real-time application support, Skype, YouTube, so on. The past few years, we are seeing a lot of cloud-based services. So we have storage services provided by Dropbox, Apple's iCloud, Amazon's S3, which stands for Simple Storage Service. There are also cloud-based services which provide virtual servers, for example, Amazon's EC2. And there is service provided in the cloud for data processing. This is through the Elastic MapReduce of Amazon. Database services, which is provided by the RDS. With that history, let's look at the application architecture. Majority of the applications follow three types of architecture. One is the client-server architecture. For example, applications like the web, email, FTP follow this. Then there is the peer-to-peer architecture. Applications like the BitTorrent, Gnutella follow this, and then there is a hybrid of these both, and applications like Skype and Instant Messenger follow this. Let's look at these architectures in a little bit more detail. In client-server architecture, the client is the device that initiates a connection to the server, and these clients are not always connected to the internet. They are intermittently connected, and not only that, over time, they may have different IP addresses, maybe because they get IP addresses via DHCP. The server, on the other hand, provides specific service. For example, the Google server provides search functionality. The Amazon server lets you buy stuff from the Amazon website. Often, these servers employ a server farm. You think you're contacting one specific server based on one IP address, but it could be directed to any of the servers in the server farm. And these servers, since they are providing a service, are always on and their IP addresses don't change that often. We can consider them almost fixed. In contrast to the client-server architecture, in pure peer-to-peer architecture, there is no concept of a server. These end systems coordinate to provide a given service. So these architectures have mainly arisen in the context of sharing music files or video games. For example, you have the latest Lady Gaga album and you want the Nirvana album, where you're ready to share your MP3s in return for other people's MP3s. There is no designated server that is providing this particular service. It's like people like you and me wanting to share files and thereby coordinate to achieve this sharing service. So in this architecture, these end systems may be intermittently connected. You don't always keep your computer on all the time. Not only that, the IP address of your computer can vary with time. Achieving the desired functionality, that is that of sharing on such systems, tends to be very complex. But the good thing about them that this is a very scalable system because it is distributed. If some node fails, not a big deal, there will be someone else sharing the same files. Pure peer-to-peer systems are a bit of a rarity. What often happens in practice is a hybrid architecture where the initial contact is to a central server, but after this point, the end systems talk direct. For example, when you're doing instant messaging, you don't know the status of your buddies, whether they are online, offline, and what their IP addresses are. So what is often done in the implementation is that your buddies, when they come online, are going to register their IP address with a server. You, when you want to talk to them, are going to contact this server, and this is going to provide their IP address to you. And after this point, you will directly contact the particular buddy and chat with him. So this is the user. You contact the server, which provides the IP address of your buddy. Then you establish a direct connection to your buddy, and as a consequence of this, you chat. As you can see, this is a mix between the client server and peer-to-peer. There are plenty of applications out there, and there is a protocol associated with these applications. For example, the protocol associated with email is SMTP. The protocol associated with web is HTTP. These protocols could be standardized, in which case the standard is specified as part of these RFCs, or it could be proprietary, in which case no one knows the actual details of the protocol. And these protocols employ transport layer services. For example, email uses TCP, web uses TCP. The real-time applications often use UDP, sometimes TCP also. What do these application protocols define? We have seen this many times before. Like any other protocol, they define the type of messages to be exchanged, the message syntax, that is the fields in the message, this message semantics, which is what is the meaning of the information carried as part of these fields, and rules for when to send and how to act on messages. Many of these application protocols also have a companion protocol that specifies the format of the data exchanged. For example, with the web service, you have the HTTP protocol associated with it, and the companion protocol of HTTP is HTML, which I'm sure all of you are aware of. HTML tells you how the web page should be rendered in your web browser. Similarly, SMTP, which is the protocol associated with email, has two companion protocols. One is the RFC 822 and MIME, and these define the format of email messages. And then there is something called an application process or a program. These are different from application protocols. An application program or a process actually implements the application protocol. For example, the Internet Explorer is an application program. Chrome is also an application program. Firefox is also an application program. All of these implement HTTP to provide web access. The difference could be in the GUI, that is the user interface. We have already seen this before. These processes are identified by an IP address port, and popular services have well-known port numbers. For example, 80 is the port number for web, 25 is the port number for the email service. I am flashing this figure so that you know we are looking at application to application layer communication now, and this is achieved by making use of the transport layer services at both endpoints. And the actual flow of packet goes all the way down, up, down, up, down, up in this fashion. So to summarize, over the past 4 decades, there have been an explosion of applications. Each decade sees a few killer applications. These applications follow 3 predominant architecture types: client-server, peer-to-peer, or a hybrid between both. There are many application protocols which are relied upon to provide a specific internet service, and these application protocols often have some supporting protocols, and they can have different implementations as well. That is, application processes that implement this particular protocol. Up ahead, we will look at some popular applications.